Hello guys, how could the bacteria in our body know the shape of us? And how does the small ant in a forest know the shape of the forest? Similarly, we humans are inside the Milky Way. So how did we take pictures of it? If we thought they took the photo by going outside of the Milky Way, that's not possible. Humans live on a small Earth, which is part of the solar system. The Milky Way galaxy has around 100 to 400 billion stars like the Sun. Among them is our Sun. The Milky Way is so big, we haven't gone outside of it. So how did we get photos of it? Warm greetings, I'm your Mr. Ajish. We have taken photos of many galaxies from Earth, but to take a proper picture of our own Milky Way galaxy, we would need to go out of Earth about 300 trillion kilometers to get the right angle. Voyager 1 satellite is the only man-made object that has gone the farthest from Earth. It was launched in 1977 and is moving at a speed of 61,000 kilometers per hour. It has traveled about 21.2 billion kilometers. 1 billion equals 100 car-hours. At that speed, Voyager would take 562 million years to reach a spot far enough to take a full picture of the Milky Way. Before talking about galaxy photos, let's understand what a galaxy is. Galaxies are categorized into three types. Elliptical galaxy, if the shape is elliptical. Spiral galaxy, our Milky Way is spiral. Irregular galaxy. Galaxies that don't have a regular shape. Most galaxies are spiral or elliptical. The diameter of our Milky Way galaxy is about 100,000 light years. A light year is the distance light travels in 1 year. A part of our Milky Way is visible from Earth, especially in dark, light pollution-free areas. In the US, power cuts are rare. But once during a power cut, many people reported seeing strange lights and thought they were UFOs or aliens. It was just the Milky Way, which they hadn't seen before due to light pollution. With light pollution today, the Milky Way is hard to observe. Using Google, we can find less light-polluted areas in India where we can observe it with the naked eye. Research on galaxies began during the time of Aristotle. Galileo discovered that the Milky Way is full of stars. In 1785, British astronomer William Herschel divided the sky into 600 zones and counted stars in each. He proposed that brighter stars are closer and dimmer stars are farther. He published the Herschel map. This was the beginning of mapping our galaxy. In 1900, Jacobus Kapteyn confirmed Herschel's map through photography. In 1910, Henrietta Swan Leavitt made significant contributions by measuring the distances of stars based on their brightness. In 1907, Harlow Shapley discovered that we are not in the center of the galaxy. This has now been confirmed. In 1920, Edwin Hubble continued research into galaxies. Now scientists are accurately mapping the shape of the Milky Way and our position in it. How can they do that? Think of living in a house. You may not know its exact structure from inside. But by looking at nearby houses in your town, you can guess the shape of your house. Similarly, by studying thousands of other galaxies, scientists can predict the structure of our own. There are billions of galaxies in the observable universe. If you point a finger at the sky, there may be many galaxies behind that finger. From this vast data, scientists found that most large objects in the universe are either spherical like planets or disc-shaped like galaxies. Galaxies often look spiral, while planets and asteroids are more globe-shaped. From observations, they predicted that about 90% of galaxies are elliptical. But researchers didn't stop at shapes. They studied for 50 to 60 years more deeply. They tracked the movement and distance of stars, radiation data, and more. Our galaxy is flat and spiral with around 600 billion stars like the Sun. Besides stars, data on star formation and nebulas are constantly being updated. The Spitzer Science Center has been collecting UV, infrared, and visible light data for half a century, which helps scientists model the Milky Way shape. The photo you see of the Milky Way is not from a camera. It's an artwork based on accurate observed data. This shape is called a barred spiral galaxy because the center looks like a bar. This bar shape is due to the massive black hole at the center, surrounded by about 10 million stars within a distance of 1 light year. From the center, two dominant arms emerge, the Scutum Centaurus arm and the Perseus arm. Between them are three smaller arms, the Sagittarius arm, the Norma arm, and the outer arm. A small branch called the Orion spur comes from the Sagittarius arm. Our solar system is located in the center of the Orion spur, about 26,000 light-years from the galactic center. Interestingly, if you look at the galaxy, it appears like stars are only in the arms and not around them. But stars are actually equally spread. It's just that nebulae in the arms make them appear denser. A nebula is a dust cloud where stars are formed. So all the arms are star-forming regions and look thick. Our sun revolves around the galactic center at 230 kilometers per second. While this sounds fast, it's actually slow compared to the galaxy size. The sun would take 213 million years to complete one revolution around the galaxy. Only one side of the arm is visible at night because our solar system is tilted about 60 degrees. We struggle to understand galaxies due to their enormous cosmic scale. It requires billions of years of observations. The way galaxies rotate is still puzzling. In galaxies, stars on the outer edges rotate faster than those near the center. This is different from our solar system, where planets near the sun orbit faster. Due to angular momentum, the center of a galaxy should flatten, and the arms should fade over time. Eventually, a spiral galaxy should become a circular disk, but the Milky Way has kept its spiral shape. Scientists call this the winding problem. The most accepted explanation is the density wave theory. Think of it like a traffic jam. Though cars move, the jam stays in one place because new cars keep entering and old cars leave. Similarly, stars are formed in the arms, then move out, and new ones are formed. This supports the density wave theory, which helps explain how the spiral shape is maintained. Another theory is that spiral shapes may be due to wave interactions caused by the galactic core's bar, but this hasn't been definitively proven. Scientists recently discovered a break in one of the Milky Way's arms. This is the first time such a break in star leakage has been found, along with the formation of a new branch. I'll share more updates as scientists publish more findings. Our neighboring galaxy, Andromeda, is 2.5 million light-years away. Research suggests that Andromeda and the Milky Way will collide after billions of years. Will Earth be destroyed? Number. Collisions between stars are extremely rare due to the vast empty spaces between them. So even if galaxies merge, most stars won't collide, and galaxy collisions take billions of years, far beyond our lifetimes. Just like you can't photograph your house from inside, but your neighbor can, we can't take a picture of the Milky Way from within, but we can photograph Andromeda. Similarly, someone in Andromeda could capture a photo of our Milky Way. Lots of curious things are yet to be discovered. Stay tuned with Mr. Ajish. Thank you.